Hey students, in this video we're going to cover the law of sines. So we use the law of sines and the law of cosines to solve a right triangle based on the information that we're given. We will use the law of sines if we're given two angles and any side in a triangle, or if we're given two sides and an angle across from one of those sides. So you may remember from geometry that you have the two cases of an angle, and the side would be, you either have angle, angle, side, or angle, side, angle. And the two sides and an angle across from those are going to be side, side, angle. So the law of sines helps you solve a triangle, an oblique triangle, which is just a triangle that's missing a right angle, or it's a triangle that doesn't have a right angle. And so the law of sines is this ratio of A over sine A equals B over sine B equals C over sine C. We can flip all of these fractions over and also have sine A over A equals sine B over B equals sine C over C. So clearly, in order to use the law of sines, one of those three ratios has to be complete. It's a very straightforward process. And again, you can only use this for angle, angle, side, or angle, side, angle. And then when we talk about side, side, angle, which is the ambiguous case, we'll see the different things that could happen there. So for the first example, we have to solve this triangle, and we're going to round the angles to the nearest degree and the sides to the nearest tenth. So the first thing that we should immediately know is that given two angles in a triangle, you can always find the third by adding the two that you know and subtract those from 180. So 68 plus 24 is 92, and 180 minus 92 is 88. So we know this angle C is 88 degrees. So we'll put the measure of angle C is equal to 88 degrees. And that's no trigonometry, that's just basic geometry. So now, according to the law of sines, we can just make ratios to solve for side. So we're trying to solve for side C and side B. And again, the lowercase letters are just the sides opposite these angles. So first, let's say we want to solve for side B. Then we want the ratio that involves sine A since it's complete. Angle A since it's complete. So we would have the sine of 24 degrees divided by 11 is equal to the sine of 68 degrees. You know what? Actually, let's do this the other way around. So when we're solving for a side in the law of sines, we want to use the form of the formula with the sides on top. It'll just be quicker calculations. So we're going to start this over. And so we're going to have 11 divided by the sine of 24 degrees equals, we don't know side B, and so that's going to be divided by the sine of 68 degrees. So all you have to do is make sure your calculator is in degree mode. And so obviously to solve for B, we're going to multiply the sine of 68 to this side. So the sine of 68 degrees times 11 divided by the sine of 24 degrees is equal to B. So we're just going to put that in your calculator. Again, make sure your calculator is in degree mode. So we're going to have sine 68 times 11 divided by sine 24. And I get 25 it says to the nearest tenth for sides, I believe. So we're going to say B is 25.1. So 25.1 inches. All right, and so now we can do this exact same thing to solve for C. We're just going to make a different ratio for side C. We can have 11 divided by sine 24 degrees is equal to, so side C divided by sine 88 degrees. And then if we multiply the sine 88 to the other side, we get the sine of 88 degrees times 11 divided by sine 24 is equal to C. And so we'll just put that in the calculator. So sine 88 times 11 divided by sine 24. And I get 27.0. So that equals 27.0. Now, from geometry, you should remember that the longest side is across from the widest angle, and the shortest side is across from the most narrow angle, or the narrowest angle. So that all of our numbers make sense in context. The 27 is the longest side because 88 is the widest angle. 68, the side that's 25.1 is in the middle because 68 is the middle angle, and 24, which is the most narrow angle, is across from the shortest side, which is 11. So in context, our answers make sense with what we know from geometry. So then for example 2, we have a case of, so if we look at our ratios, we don't have any complete ratios. So we know angle C, we know angle A, and we know side B, but we don't know angle B. But remember, anytime you're given two angles, you can always find a third by adding the two that you know and subtract from 180. So angle B is 78 plus 36 is 114, and 180 minus 114 means this angle is 100, not 116. That's just terrible math. That was 114, I said, right? So 180 minus 114 is 66 degrees, excuse me. So now we have this complete ratio with angle B and side B, and we're looking for side A and side C. So let's say we'll put side A in green. So we know that A divided by the sine of 36 degrees is equal to B divided by the sine of 66 degrees. And so again, our next step is just going to be to multiply the sine of 36 to the other side. So we get A equals the sine of 36 degrees multiplied by 28 divided by the sine of 66 degrees. Cool. Put that in a calculator. So we get sine 36 times 28 divided by sine 66, and that is 18.0. So A equals 18.0. So 18.0. And so now we're going to do the same thing for side C. And so for side C, it's going to be the same thing. So C divided by, oh, excuse me, where did I go? So C divided by the sine of 78 degrees is going to equal 28 divided by the sine of 66 degrees. And if we multiply by sine 78, we get C equals sine 78 degrees times 28 divided by sine 66. And let's see what that is. So sine 78 times 28 divided by sine 66, I get 29.98. Rounding to the nearest tenth is going to make that 30.0. So again, in context, it makes sense that the side that is 70, the side opposite 78 is the longest, the side opposite 36 is the shortest. So again, in context, all of our answers make sense. So now we get to the ambiguous case where we have two sides and the angle. So again, the ambiguous case is you're given two side lengths and an angle across from one of those sides. When that happens, one of three things could happen. You could have a case where with those two sides, you can't form a triangle with the given information. We could make one unique triangle like we've done in the previous two examples, or we can have two distinct triangles, and we'll talk about that in when we get there. Right. If you want to see how this works, if you click on this link that is the ambiguous case, it shows you how and when you have no triangle, one triangle, or two triangles. Now, if you're into like memorizing information, here is a list of scenarios that you can use instead, and that's what we're going to do. So we're going to use this formula H equals B times the sine of A. And H is the height of the triangle. If you draw a perpendicular from the angle down to the side that you know. You don't actually have to draw anything. You can just do the calculation, and then these are the necessary conditions to produce a particular outcome. So first is if A is less than H, you don't get a triangle, or if A is less than B, you don't get a triangle. So now if A is less than B, we're talking about A is the side that is across from the angle that you're given. So it could change. Don't let this fool you. It's not always just A and B strictly. A is the side that is across from the angle that you're given. Like if we look at example 3, we're given an angle that's 82 degrees and the side that's opposite that angle is 29. So now if we flip those around where we made B 29 and A 20, then we wouldn't be able to form a triangle. But again, it's the A is the side that is opposite the given angle. That's how we know. All right, so anyway, so for example 3, we have to determine the number of triangles. If at least one triangle is possible, we need to solve for that triangle. Okay, so first, we need to determine how many triangles we have. So our height is going to be, so B is 20. So 20 times the sine of angle A, which is 82. So let's put that in the calculator. So we have 20 sine 82, and that is 19.8. So that equals 19.8. So in this case, so A is 29 and H is 19.8. So when A is greater than H, but let's see, so A equals H. I'm sorry, we're just at this condition here where we have A is greater than B, we get one triangle. So we see that A is 29, B is 20, so we get one triangle. So it still doesn't hurt to do this calculation. We didn't need it for this one, but right here, since A is larger than B, and again, A is the side opposite the given angle, we should get an obtuse triangle. So let's see. So now we can solve for the other two angles that we have and the missing side. So remember our formula is sine A over A equals sine B over B equals sine C over C. So we know everything about the A measurements. So we're going to solve for angle B first. So we're going to have the sine of 82 divided by 29 equals the sine of angle B divided by side B is 20. So to solve for B, we're going to first multiply the 20 to the other side. So we're going to get 20 divided by 29 times sine 82 equals B. So we could just say 20 sine 82 divided by 29. That's all we're really doing. I'm sorry, not equals B, equals sine B, my mistake. So remember, if you were solving for an angle, you need to use the inverse sine function. So that's going to mean that the inverse sine of 20 times the sine of 82 divided by 29 is equal to B. And that's literally what you put in your calculator, all of that information. So we're going to have sine inverse 20 times sine 82 divided by 29. And we're going to say we round to the nearest degree. So I get 43.07. So we're going to say angle B is 43 degrees. So angle B is 43 degrees. In this case, so now we know angle B is 43 degrees, so we'll put, all right, where can we write this where we don't gum up stuff? Give me a moment. So we'll cross this out. So now we're going to put the measure of angle B is 43 degrees. So that immediately should allow us to find the measure of angle C, because we can just add A and B, and that's 125. And so that means that the measure of angle C is 55 degrees, because we add the 82 and 43 and subtract that from 180. And so now all we have to do is find side C. So to find side C, we're going to use angle A and this side and angle C and solve for C. So we're going to have A is 29. So 29 divided by the sine of 82 is equal to side C divided by the sine of angle C, which is 55 degrees. So sine 55 times 29, times 29 divided by the sine of 82 is equal to C. And in a calculator, that's going to be sine 55 times 29 divided by sine 82. I get 23.98. So that's just going to round up to 24. So 24 is equal to C. So now up here we can put C equals 24. So B is the smallest angle, so it has the shortest side. C is the middle angle, its side length is in the middle. A is the widest angle, and it has the longest side. So again, all of our information in context of what we know from geometry is still true. And in this case, again, just using our necessary conditions, we see that we should have gotten one triangle, and we were able to solve for that. For example, 4, we have to determine the number of triangles. And so again, we're given an angle and the side opposite that angle. So if the other side is larger than that value, we have no triangle. So this is the case here where B is greater than or equal to 8. So 19 is greater than or equal to 8. So in this case, it is no triangle. So we don't have to do any work. There's just no triangle that can result from this. And so now for example 5, the ambiguous case, which is going to give us 2 triangles. Let's see what happens. So we're given angle A, the side opposite of angle A, and another side. So remember our calculation is that H is equal to, in this case, is going to be C times the sine of angle A, because we're given side C. So that's going to be 28 times the sine of 39, and that equals, who knows, 28 times the sine of 39 is 17.6. So our H value is, so H is less than, so we're looking at H is less than A is less than B. So in this case, H is less than A, which is less than, again, the B is interchangeable. We're going to say C in this case. H is 17.6, A is 26, and C is 28. So in that case, we end up with 2 triangles here. It's the ambiguous case where we get 2 different triangles. And so let's see how we get both of those triangles. So first, let's say we want to solve for angle, C. So we have to solve for angle C first because we're given side C. So we're going to have the sine of 39 degrees divided by 26 equals the sine of angle C. And you know what? We're going to say C1 because that is the first angle that we can get. So the sine of angle C1 divided by C, which is going to be 28 regardless of the triangle. So we're going to multiply by 28. So we get 28 sine 39 degrees divided by 26 equals the sine of our first angle C. So in this case, we're going to get, now this is going to be true. We don't have to do two calculations. We're going to do sine inverse of 28 times the sine of 39 divided by 26. And that's going to be our angle C. So when we do that, we're going to get sine inverse. Now, if we get a positive, this is going to give us a positive value because that number is sine 39 is positive. So we're going to get a positive value here. So sine 28 times sine 39 divided by 26. Remember, inverse sine is defined in quadrant 4 and quadrant 2, in quadrant 1. So when we get this positive angle, we get 42.6. So we're going to round to the nearest degree. So angle C is about 43 degrees. But remember, sine is positive in 2 quadrants. Sine is positive in quadrant 1. So we get an angle here that's 43 degrees. But remember, in quadrant 2, there's an angle that uses 43 as a reference angle, and it also has a positive sine, the same positive sine value. So our first angle is 43 degrees. Our next one is 180 minus 43 degrees, which is 137. And so that's our C2 angle. It's the angle that uses 43 as a reference angle. So our angle C1 is 43 degrees. Our angle C2 is 137 degrees. So if angle C1 is 43 degrees, that means that angle B1 is 180 minus 43 minus 39. We subtract angle A and angle C, and that's going to be 180 minus 82. So it's at 98. 180 minus 43 minus 39. Yeah, so it's 98. So angle B1 would be 98 degrees. Now, in the case that we're using angle C2, then angle B2 is going to be 180 minus 137 minus 39, which equals, I'm pretty sure it's 4 degrees. So 180 minus 137 minus 39 is indeed 4. So that's 4 degrees. So in one case, we get a triangle that has 3 angles that are 39, 43, and 98. Or we get another triangle that has angles that are 39, 137, and 4. So if we go with the first triangle, we can then find side B1, lowercase b1. So we're going to have B1 divided by its angle, which is 98 degrees, sine 98, I'm sorry. So sine 98 degrees, and that's going to equal, we'll use the angle that we know. So 26 divided by sine 39. And so then when we multiply, we get B1 is equal to 26 divided by sine 39 times the sine of 98. And whatever we get, that is the correct answer. So 26 divided by sine 39 times sine 98. And that is 40.9. So B1 is equal to 40.9. So up here, we'll put B1 equals 40.9. And over here, we'll put whatever we get for B2. So then for B2, so B2 divided by the angle that's opposite that is 4 degrees. So sine 4 degrees is equal to 26 divided by sine 39. That's going to imply that B2 is 26 divided by the sine of 39 times the sine of 4. And so that's 26 sine 26 sine 4 divided by the sine of 39. And that is 2.88, or we're going to say B2 equals 2.9. So again, all of our answers make sense in the context of what we know about triangles. Longest side is across from the widest angle. Shortest side is across from the smallest angle. So again, in the case where we get two triangles, the reason we get two triangles is that this inverse sine value produces a positive number. And sine is positive in quadrant 1 and quadrant 2. So you'll always find the quadrant 1 angle first, and then to get the other possible angle, you do 180 minus that angle that you find, because that's the angle in quadrant 2 that also has a positive sine value. And then you make your two triangles accordingly. And so that's what we did. We did one triangle that has the information I'm putting in this box, and the second triangle is the triangle with all of the information below that box. Anyway, that concludes our video for the law of sines. Again, it's useful for two angles and a side, or two sides and an angle. You do not have to commit any of this to memory. You will be able to use this information in its written form. All right, thank you.